I'm David Willson, mechanical engineer and technical content creator at Fictiv. Welcome to episode 4 of the FictivMade series. Today, I'll take you through how to create a quote on Fictiv's platform, set up project requirements, and review DFM feedback. At this phase in the multi-tool phone stand project, I've refined my design for injection molding using insights from prototype iterations. Now it's time to get it ready for manufacturing. To start a new quote on the platform, I selected injection molding for the manufacturing process and uploaded my CAD files. I had to specify that the metal blade would be CNC machined and then insert molded. Next, I filled out my project requirements, including production location, development stage, and mold life. Each part then had to be configured with specifications for material, finish, color, and quantity. After using our materials AI for advice, I chose PCABS due to its moldability, impact resistance, and moderate flexibility. For the overmold grip, I chose a 70A Shore TPU for a good mix of rigidity and compression with lower risk of delamination. For finish, I requested MT11000 for the main parts, which is a light matte texture and a high polish finish for the recessed surface of the Fictiv logo. I also selected specific Pantone colors for our Fictiv green and carbon to ensure accurate color matching for the respective parts. One of the big advantages of quoting on our platform is the instant DFM feedback. Let's walk through some key features to check. Draft. Adequate draft is critical for part release from the tool. The analysis shows I have sufficient draft with 1 degree for most surfaces and highlights where slides are needed for undercuts in the hinge area. The color breaks help visualize the parting lines, which are drawn out in a separate review box also. Wall thickness. The auto DFM highlights areas that are thicker or thinner than the nominal 3mm wall. Thick areas, shown in red, can cause longer cooling times and sink marks. It's often safer to core out these sections if the design allows. Thin areas shown in light blue, like the overmold ribs, can be steel safe, meaning they can be thickened later by removing tool steel. Another great feature of the Fictiv platform is the ability to annotate slides to communicate your intentions on the DFM. Now I'll walk you through some of the newer features for injection molding DFM on our platform. The DFM shows the gate type and allows you to provide feedback on the location. I saw that the TPU overmold would cover my gate location on the ribs, so it wouldn't be a factor cosmetically. A quick look at a mold flow simulation is helpful to understand how the material will flow through the part. This is helpful for predicting and preventing knit lines and short shots. You can request a more detailed mold flow analysis at an additional cost when filling out your project requirements. The 3D DFM shows ejector pin size and locations that are required for pushing the part out of the tool. After filling out project requirements and reviewing automated DFM, I simply request a quote and receive a full DFM report before placing the order. Detailed DFM. After reviewing the automated DFM and requesting the quote, I received a PowerPoint with detailed DFM feedback for each part. This helped us resolve other issues that required back and forth communication. The detailed DFM explains the same topics as the auto DFM, such as draft, thickness, parting lines, core inserts, gating, weld lines, and ejector pins. It also allowed us to resolve some other design details, such as the logo surface finish and thin recesses for the measurement markings that had to be changed. Fictiv's mold library on the platform is another great resource that provides full transparency into your molds after you place the order. You can select a tool and manufacture additional parts with it without going through the entire quoting and DFM process again. You can also follow along with each step as the tooling is developed and validated. That's all for this episode. Thanks for watching, and stay tuned for the next segment where we'll take a look into tooling fabrication for the injection molding process.